Okay, so MATLAB tutorial seems like I updated it last semester because the date that I see is April 8th. So it was updated towards the end of the last semester. So I guess this is the one that I shared with you on Canvas in your course section. So MATLAB is a descriptive or scriptive programming language. It stands for Matrix Laboratory. There's a MATLAB, basically the matrices that you used in LabVIEW and in other programming languages, if you have used matrices. Basically, MATLAB revolves around matrices and arrays. And it just makes working with matrices and arrays so simple and so easy that the stuff that you do in LabVIEW perhaps it takes you 15, 20, 30 minutes. MATLAB can do it in just one line or a couple of lines, so very quickly. It's a very powerful engineering programming language dedicated towards engineering, but you can do general programming in this as well. It is used very widely, very commonly in industry, as well as pretty much, I would say, in all the engineering institutions, universities, and colleges, not only in US, but around the world. And again, as I mentioned last time as well, it's not a free software. Student version used to be $100. I don't know if it is still $100. But Octave, which is Linux-based, but they have released, of course, the GUI version and Windows. It is available on Windows platform and Mac platform and Linux platform, on all the platforms. So Octave is pretty much similar to MATLAB. It's free. And most of the functions are there that you have in MATLAB. Those functions are also implemented in Octave. So I have not found Octave to be any less than MATLAB in all the work that we do. It's quite possible that the advanced stuff that you're doing in MATLAB, if you do, people who are doing advanced stuff, it's possible that is not yet implemented in Octave, and MATLAB is important for that. But as I said, for us, Octave works perfectly fine. So if you have downloaded Octave and installed it, and I'm going to be using Octave myself, actually. I have it at home. I do not have MATLAB at home. Even in my office, I don't think I have installed MATLAB. I think I have installed Octave. In classrooms and labs, both Octave and MATLAB both are installed in every classroom, in the open lab, and everywhere. So this is where you can download the download GNU Octave, as I think I showed it to you last time as well. So make sure, I don't know if you have downloaded it or not, but it is available on all platforms. So make sure for Windows, if you have not downloaded it yet, make sure you download install the exe file for Windows. So download and install the exe file. And you can do it right now if you have not installed it yet. Just do it right now. It's not going to take you long. It's only 5-10 megabyte. If you have, and if your internet speed is good, then it will download quickly, and then you can install it. Also, you can use Octave from the cloud. I believe that I also showed you last time, but I'm going to go ahead and show it to you again. If you're working on any computer, it's not your computer, it's any computer, and it does not have Octave installed, then you can just go octave-online. I believe it's net or org, I forgot. But let's see. Online Octave right here. So you can also access it from the cloud through any browser. And if you log into Octave, that gives you different options. So let's say if I log in with my Gmail, then not only you can, of course, execute the code in what we call the command window, but you can also save your programs and write your scripts and save them in the online Octave Online. And I think if you logged into the cloud using your Gmail, then I think most likely it will be saving in your Google account. So you can use either online or I prefer to install it. So I will prefer that you install it as well on your personal computers. But again, if you're using a computer where you don't have Octave and you don't want to install it, then you can just use through the cloud. You can create scripts over here and all those things and save them and run them again. So plenty of opportunities available to use Octave, which is an alternative of MATLAB. I'm going to go ahead and let's go ahead and open. I have the older version installed, 8.3 is still. The newer version, as you saw, it's like 10.2. Not much difference. It's possible they must have included some new functions, but as I said, even older version works perfectly fine. And the environment is also pretty similar to the new environment. I think I have installed the newer version at the office, and it's the same environment. So the environment is pretty straightforward. You have this window, and usually if you have installed it, and if you open Octave, and there are two, Octave command line interface and GUI. Both are going to be installed. Just use the GUI version because it's easier to use, and you can write code in editor and stuff. Command line interface, again, you can still use it, especially if you are familiar with Linux. But do not really open just command line interface. Open the GUI because it's very close to the MATLAB environment. But it's going to install both. When you install Octave, it's going to install command line interface right here, CLI, and then it's going to install GUI, both of them. So just use the GUI version. Interestingly, at the office, whenever I open the GUI version, it automatically opens command line interface. Now, it has something to do with, I believe, Windows setting, because it happened to me before on my home computer, and I figured out a way after searching online that both windows do not open, only the GUI window would open up. So I found out a solution by searching online, because it was opening both windows, CLI as well as GUI, whenever I used to hit GUI. And I fixed it. But last time I installed in my office, again, it was opening both windows. Although I was just using GUI, I just minimized the command line interface window. But whatever you're doing in GUI, it was also reflecting the same in the CLI version. It doesn't really matter, though. It's not going to hurt anything. It was just a little bit annoying for me that why it was opening both of them, CLI and GUI, simultaneously. So I don't know if that thing is happening to any one of you, that if you open the GUI version, it is also opening CLI. If it is not, perfectly good. If it is, as I said, it's not going to hurt anything. Just work in the GUI version and minimize the CLI version. And again, there's a workaround for that fixes it. And I totally forgot how did I fix it on my home computer, because it was happening. When I installed this version, it was happening as well. Anyone is experiencing that after installation and opening that? No? Well, Robert, you were at the college, so, but anybody who installed on their personal computer, if you are opening GUI version, is the CLI version, the CLI window also opening up?
Yes, for me it is.
Alexander, is for you? Okay. Well, again, as I said, you can minimize the CLI window and just work in the GUI. It's not going to hurt anything. And once I figure out, I think it has to do something in Windows setting. I remember I changed something in Windows setting and then it fixed it. And I have to search for it again. I searched online how to fix it. But anyways, as I said, it's not going to hurt anything. So this is basically what you call your command window. It's right here. Now, once you install it and open it, you will also see, let me go and editor and minimize it. You will also see your editor right here at the bottom. For me, it's separate, but what you will see at the bottom, you have like 3 or 4 tabs right over here. One tab is going to be command window. One tab is going to be editor. There will be some documentation tab as well. I closed all of them. If I go to Windows, show documentation. So like I have the documentation tab, and you will have that tab over here. If you click on that, it's going to switch to the documentation window or something like that, if I remember correctly. So you will have all these tabs down over here. You can close those tabs if you want, and you can open them again going to the window, and then you can open a bunch of tabs, whatever is available. Also, when you run it for the first time, you will see, I believe you will see a command no, this is the command. You will see a command history window on the side. You may also see file browser, if I remember correctly. So a couple of windows you will also see on the side once you run it for the first time. Again, I don't really need it, so I close it. This window is also, it's pretty useful, the command history window, because it records all of your previous commands from previous sessions and from the current sessions. So if you have to recall any command, you can just go ahead and click on that command, and that command is going to appear in the command window. So the command history window is useful window. I found it pretty useful. Other windows, they're not very useful, so I close them usually. But the workspace is very straightforward. This is where you can basically put your commands, and you can see the results. And also, you can, when you run your program through your editor, you can see the results in the command window as well. So command window is basically your basic environment where you will see all the results. Now, the other window that you will be using, so you're going to be using command window to see your results. And to write the programs, you're going to be using the program editor. So I'm going to open the window. I closed it. Show editor. So to write your programs, you're going to be using the Octave editor. Now, a long time ago, I remember when I was doing the bachelor's, MATLAB did not used to have its own editor. So we used to just use the Windows text file and used to save file as .m instead of txt, because MATLAB files and Octave file extension is .m. But now with MATLAB editor and Octave editor, it is pretty, it has made life a little bit simpler for troubleshooting. If you make a mistake or something, it can kind of guide you. It can show you that you're making a mistake at that line, and it uses different colors to do different things. So the editor is really good in MATLAB and in Octave as well, both of them. So in the editor, you're going to be writing your programs that you have to submit for your homework. All the programs that you're submitting for your homework, those programs are going to be written in the editor. Those programs you're going to save as .m file, which is the default option. So if you want to save a file, let's say this is the first program. And if you save a file, let me see. Let's go to class and classroom. And let's say if I save it as MATLAB 1, then it's going to save the file as .m file, which is the default format. As you can see, I use percent and everything is in green. Percent is used to write comments in MATLAB. So anything that is written after percentage sign, that is considered to be comments. And those comments are not executed when you are executing your file. So these are comments that you put in your program. A good programmer always put comments in the program, not only for other people, but for himself or herself as well. Many times, if you're creating a long program, you're creating a logic. When you're writing a program at that time, you are zoned into that program as how to create a logic for this thing. And many times you figure that out. And sometimes it's very complicated logic. And then you just, put the logic, program is running, everything is good. After a few years, you pick that program up and you're going through it, your own program, and you're like, what did I do? What did I do at that time? You have no clue, because creating logic, especially if it is cumbersome, it works. It works especially at that time because you are the one who's creating, but later on, you may not even remember how did you create that logic. So it is always wise to put comments in your program, not only, as I said, for other people, but for yourself as well, so that you would remember, okay, this is what I did back when I was writing this code. This is the logic that I created. So anytime you see a percent sign and anything written in green basically in the editor, that is going to be comments, and those comments are not going to be executed. They will be ignored when the file is being executed. So this is where you're going to write your function. Once again, I detached this editor from the command window. It will be at the bottom. You will see the editor window at the bottom. I usually detach it so that I can see both of them kind of side by sides. So when I'm running a program, then I can see the results over here. If I don't detach it, then of course, once I execute a program, that I have to jump to the other tab to see what are the results. So I like to keep them separate, just for the visibility purpose. It's easy to look at both of them. Okay, so let me go to the tutorial as well. So make sure, again, as I said, download it, install it. I showed you the environment, very easy environment. Two windows you're using, command window and the function and the editor. That's it. And this is when I wrote this tutorial, I was using MATLAB 7.9. This is the editor of 7.9. This is the command window of 7.9. Again, it doesn't matter which version you're using. All of them are compatible. You know, any time you save a file as .m extension, whether in MATLAB, whether in Octave, you can open Octave file in MATLAB as long as it is .m file, and likewise you can open the file from Octave into MATLAB as long as it is .m file. Now, sometime if you are creating a file in MATLAB and you use a dedicated function that is not yet implemented in Octave, then it's an issue, because your file is going to be executed, but it's going to give you an error. And generally, Octave does know if a function is present in MATLAB, but it's not yet implemented in Octave. It does give an error that function yet to be implemented in Octave. And I have seen that in my advanced classes. Some of them, they use dedicated functions, which they were not supposed to use anyways, because all the classes, as I said, signal processing or control system, you can just do everything in Octave. You don't have to use any dedicated function from MATLAB. But for some reason, some of the students did use them in different semesters, and I could not open their file. So now I specifically mention in the assignment that make sure that your code should run in the Octave, even if you are writing the code in MATLAB. So you must ensure that it is running in Octave before you submit the code. If it is not, then you have to go and fix your MATLAB code and perhaps remove any dedicated function that you're using that is not yet implemented in Octave. Okay, so again, don't worry about this because this is again MATLAB screenshot. You're using Octave, so it doesn't really matter. And you have the command window, you have the command window and editor in Octave as well. Okay, how to save your M file because you're submitting your M file. Make sure M file and MATLAB variables that you're going to be defining in MATLAB, both of them have the same rule. And the rule is that your file should start with a letter, should not start with a number, always start with a letter. It can contain numbers, not as the first character. The first character has to be a letter, but it can contain numbers. And also, the only special character allowed is underscore. The only special character allowed is underscore. Now, again, if you're using Octave, Octave is compatible not only with MATLAB, but Octave is compatible with a bunch of other programming languages. If I show you the preference. Now, observe under editor, observe that it can do C++, Java, it can do Perl, Bash, Dev, Bash, text. The editor can be used to write C++ codes, Java codes, Perl code, text file, and stuff like that. Now, the file name format for C++, Java, they may allow you to use other characters as well, even spaces. So Octave does not differentiate as far as file name is concerned. But if you open the same file in MATLAB, and if you don't follow the file naming format of MATLAB, you cannot open the file in the MATLAB. So since we are using Octave as an alternate of MATLAB, please make sure that you stick with whatever the requirements of MATLAB are. And the requirements for MATLAB are that your file name should always start with a letter. It can contain digits, numbers, but that should not be the first character. And the only special character that is allowed is underscore. You cannot use a hyphen. You cannot use a space or anything. Again, saying that, I'm not saying that if you're using an Octave, as I said, it can save in different programming formats. You may still be able to open it even if you use hashtag, but you cannot open it in MATLAB. So as I said, just be careful while defining the file name and stay away from the rules that do not apply on MATLAB file name. Now, same rules apply for the variable definition of variable in MATLAB. For example, I can define a variable as Masood underscore Ijaz underscore 123 and assign a value 23345 as a perfectly good variable, because my first character is a letter and a special character is underscore, and I have numbers in my variable name as well. The maximum length of a variable name or a file, I believe it's 63. Somewhere I have put somewhere here. Right here, 63 characters. So the maximum length of a variable is 63. Name length max. Let's see. Name length max. So 63 characters. And nobody's going to define a variable name, 63 characters. It's just too many. Make sure when you're defining a variable name, try to define a name that suggests what type of value the variable is holding. That's always wise. It's not a requirement, but that's always wise. For example, if your variable is holding voltage, then let's represent as a V or represent as volt. It's equal to 45, whatever you want, just to show that this is the variable where the voltage is being held. Now, uppercase and lowercase characters you can use, and they will be considered as two different variables. For example, if I do lowercase volt, then uppercase and lowercase volt, they are different variables. How do we know? To see what variables are present, you can write the command who, and it's going to show you that right now you have 4 variables. Masood Ijaz 123 volt uppercase, volt lowercase, and ANS. ANS stands for, of course, answer. And answer is a default variable. Anytime you do not assign a variable to hold a value and you're performing some sort of calculation or you're looking at a value, and you don't assign any variable to hold that value, then the value is automatically assigned to the default variable, which is called ANS or answer. So the value that is in the answer is 63 because I did not assign any variable to hold the value that is returned from name length max command. So answer held that value of 63. The rest of the values, as you can see, I assigned to different variables. And those variables are present in this list. So observe, you have the uppercase VOLT and lowercase VOLT. They're 2 different variables. So in MATLAB, when you're defining the variables, they are case sensitive. So, don't remember in PSpice when you were defining prefixes, whether you're defining milli, uppercase milli, or lowercase m or uppercase m, both were milli. MATLAB is different. Uppercase m is different than lowercase m as far as variables are concerned. All right. If you want to clear any value that is in the memory and the command is clear, it's going to clear all the values. If you want to clear a specific variable, you can just choose that variable, clear VOLT, and it's just going to clear that specific variable. It is generally a good idea when you're writing a code, except functions. Functions, you don't use clear. And we're going to discuss functions maybe in a couple of weeks, I think. But it's a good general practice that you start your code with clear, especially if you're using matrices and arrays. And I'm going to tell you the reason as well. But clear basically clear up all the variables that are in the working space. So if I do now who, then it's not going to show me any variable because it has cleared up all the variables. So, and there's another command which is called CLC, which is called clear command window. Clear command window is basically clear the command window and remove everything that is in here, but that does not remove the values that you have assigned to any variable. It just cleans up the command window. But the values that you have assigned to any variable, it stays with the variables. Unless you use the clear command, CLEAR, then the variables lose their values. Now, why it is a good practice to use CLEAR clear? Many times I don't use it, many times students don't use it. But sometime, when you are defining matrices, we're going to discuss matrices later today. When you're defining matrices or arrays sometime, and I execute, like I'm opening your file and I'm executing your file, and your value, let's say you define a matrix A, and your value is there, matrix A, in my memory. And then I move on to the other student, open other student's file, and then other student also has a variable A with a matrix. Now, sometimes it happens that the old matrix, it does not erase properly. For one reason, or there are many reasons because of that. Let's not go in the reasons. So when I execute the new student's file, it start giving me an error. And I go to the code, I read the code, everything looks good, and then I go ahead and manually clear my space using clear command, and then pretty much 99% of the time, the code starts working fine. Because when I was running another student's file and I already had a variable with the same name that the other student is using, and it had a value, it was conflicting with the new value that the student had in his file. So although his code is written correctly, but since I already had that variable with some value, it was again creating issues with the new value. So usually when I clear my workspace, the variable space, then it clears up all those issues and program usually work. Unless there's some other error, that's a different story. So it's a good practice, I think, that to use a clear command at the beginning of your code. As I said, sometimes I do use it, sometimes I don't. But you cannot use clear command when you're writing functions, what we discuss in a couple of weeks functions. Many students do use it despite me telling them clearly don't use the clear command, but still students use it. And again, their functions do not run because of the clear command. So once we discuss function, we're going to discuss that in detail. Another thing is your up arrow and down arrow. If you do up arrow, it cycles through your previous commands. And if you do down arrow, it goes to the next command. So basically, if I open the window of command history, and if I do up arrow, then it is cycling through whatever is in the command history, as you can see. It's going up. And then if I do, it's going to start going down. So sometimes these up arrow and go down arrow, they are useful again if you want to recall one of the old commands. Sometimes, again, you're writing a big equation, and you don't want to rewrite the equation, of course. Nobody want to rewrite that big equation. So the easy way is just recall that equation either from the command history or just hit the up arrow and go to that equation. And that's very common. Saves time, and time is, of course, time is of essence. Okay. What else? Let's go and see what else I have to discuss. Number formatting in MATLAB. There are different ways that you can represent a number. It's just a representation. The numbers are still calculated with a specific number of precision points. But the presentation can be different based upon which presentation you have chosen. By default, and let me go and show you. So by default, let's say A is equal to 2.6543 exponent 2. By default, the presentation is such that the number is going to be 5 fixed point with 5 digits. So as you can see, fixed point with 5 digits. This is the default, which is called the short or short G, this data format. Short or short G. Short G is basically, it toggles between exponential representation or without exponential based upon the length of the number. If you want more precision, then you can change the number format to the long format. And to change it, you have to write format long. And then it's going to show you a lot more precision for the same number. So the format long, as you can see right here, floating point fixed with 7 digits for single class and 15 digits for double class. So right now you're seeing 15 digits for the double class format. If you want to go back to your default format, all you have to do is to write down format, and it's going to go back to your default short format. If you want engineering notation, then you do format. And again, engineering notation, they have 2 of them, short ENG and long ENG. So you can either do short ENG format short ENG. And again, everyone must know about the engineering notation. I think we discussed it sometime, I forgot. Engineering notation, of course, you have exponential format, and the power of the exponent is a multiple of 3. So if you do A, it's going to show you 265.43 exponent 0. 0 is a multiple of 3. 3 times 0 is 0. And if you do a very large number, let's say B is equal to 2, 3, 4, 5, 6, 7, 8, 9, 1, then it's going to show you B is equal to 234.5679 exponent 6, which is again engineering notation because the power of exponent is multiple of 3. And you can also do engineering notation in the long format with 15 digits. Likewise, if you want to do scientific notation, then scientific notations are long E and short E. Long E and short E. So if you do format short E and do B in there, then you will see the scientific notation. Remember, scientific notation requires you to have the decimal after the first digit from the left. And based on that, it adjusts the power of 10 exponent value. The difference between engineering and scientific is engineering has the power of an exponent to be a multiple of 3, and scientific notation has power can be any value, but the decimal point must come after the first digit in the scientific notation. So this table basically tells you different formats in which you can see the numbers. Many times I using engineering format, short engineering, because of course when we are using engineering format, exponent 6 is going to be replaced by mega, exponent -3 is going to be replaced by milli. So instead of counting the points and putting the prefix, it's better just to represent the number in the engineering format, look at the exponent and use the appropriate prefix for that in engineering. That's what I do generally, but it's always easy to just leave it as the default format and then just use it in the basic format if the number is a simple number. So this table number 1, it defines different number formats. Mathematical operators in MATLAB, the same mathematical operators that you use in math, they're used in MATLAB as well. Multiplication is asterisk, 2 times 3. Division, of course, is the division sign, forward division. Multiplication is asterisk, addition is plus, of course, and you have minus. You have to use parentheses in order to separate parts of an expression or an equation that you have to evaluate first. Again, mathematical rule that things that are written inside the parentheses are going to be evaluated first. Power, you use the caret symbol. That's the power symbol. Remember, in LabVIEW, you have to use two asterisks to represent power in the formula block. But in MATLAB, you use the caret symbol for the power. Again, mathematical rules apply, arithmetic rules apply from the left side of the expression or an equation. Anything that is written in parentheses is going to be evaluated first. Power is going to be evaluated, of course. And then from the left side, multiplication and division, whichever is coming first, is going to be evaluated, followed by, finally, addition and subtraction. So the same rules that you apply for arithmetic, they are applied in MATLAB as well. So for example, if I ask you to evaluate an expression, let's see. Let's say evaluate an expression 2 times 5 plus 7 divided by 3 minus 2 to the power 3 plus 25 divided by 50 plus 2. Let's say if you have to evaluate this, go ahead and write this in the command window. You don't have to write it in the file, just write it in the command window to see how you're going to write this equation and what will be your result. Again, use parentheses to the parts of the equation that you want to evaluate first, and then write the equation.
I think he disconnected.
I'm sorry?
Oh, never mind.
You got it?
No, I just thought you froze. Like the fan was working, but you weren't moving at all. And I was like,
No, I'm moving. I was reading something.
You were super still.
Okay. Did you guys get the answer?
I got 0.4154.
Let's see. So if I'm gonna do, let's say if I assign a variable, so if I have to go change, I can change. So it's going to be my numerator, which is 2 times 5 plus 7 divided by 3 minus 2 squared. So that's my first part, and of course I'm adding 25 into that, and of course I'm dividing the whole thing by 50 plus 2, which is 52, but just to write that the way it is, 50 plus 2, negative 16.519.
Isn't it 2 cubed?
Is it 2 cube? Okay, so let's go ahead and put it as 2 cube. So negative 2.9192. And that's the beauty of not writing the whole equation. You just put up arrow recall the equation and make any changes that you want to make instead of writing the whole thing again or copying and pasting the whole thing again. So if this is the answer that you got, then you wrote the equation correctly with the parentheses. My advice, don't use excessive parentheses. Sometimes it can get pretty, get confusion when somebody is looking at your equation. And use the parentheses at the correct spots, of course. Now, when you're writing an equation, and again, we're going to come back to equation with variables and stuff. And so let's say we have an equation. Let me go to the editor. So let's say you have determine the value of the following expression for x is equal to 5.23 and y is equal to 6.98. Let's say I want to write an equation, or I want to evaluate an expression which is a function of x and y, and let's say it is 2x plus 3y divided by 5x plus y minus 5y over 4x. Let's say this is the equation, for example. And I want to write this down and evaluate it. So I'm showing you how I'm going to write the program, because if this is one of your programs and you will have to submit it, this is what you're going to do. So first, of course, you're going to name the file. And generally, the format I ask you to submit the file is the same format: your first name underscore last name underscore ex1 for exercise 1, ex2 for exercise 2. And of course, it's going to be an M file. Now, for the first homework, it is okay if you submit all files in one program. But when you start doing for loops and functions and all those, then you may have to create separate files, separate M files for each program. I think for the first homework, I think it's fine if all the programs are in the first one. Just put comments properly that this is the program number 1, this is the program number 2, exercise number 1, exercise number 2. So when you are evaluating an expression based on the values of variables that are in the expression, the first thing that you do is you define the values of those variables. Because if you don't, and it encounters the equation, then it goes and starts looking for the variables, the values of the variables. And if it doesn't find it, then it's going to give you an error. So we start with clear, just to clear up all the values when I run the program. Now I'm going to define x is equal to 5.23. And you can also define either y in the same line or another line. If you want to define y in the same line, there are 2 ways to define that. You put a comma and y is equal to 6.98. And if you have other variables, then you can separate them by commas. If you do not want to show the values of any variable or any calculations, then instead of putting comma, put a semicolon. If you put a semicolon, it's going to assign the value to the variable, but it is not going to display those values in the command window. So generally, I prefer, if I don't want to display the value, I prefer not to display them. And I just put a semicolon. Now, you can, as I said, you can define these 2 values into 2 separate lines as well. You don't have to. You can define all the values in a single line, but it's your call, whichever way you want to do it. Semicolon is not going to display the values in the command window. It will still assign the values once this line is being executed. It's going to assign the value, but it's not going to display the value. So once you assign the values, because it is important to assign the value to evaluate the expression depends on x and y, then you assign a variable to hold the values evaluated from the expression. Now, this is not an allowed variable format. Anybody can tell me why? Why I cannot use it as the name of my variable?
Because it has the parentheses.
It has parentheses, which are special characters, which are not allowed in MATLAB. And it has a comma, which is again special character, which is not allowed in defining a variable name in MATLAB. This can be used if F is a matrix and X and Y are the indices of those matrices. So you can write this down to assign a value to a matrix F at its index X and Y. Let's say X and Y are 1, and in this case it's 5.23 and 6.9, which cannot be indices. Indices are always integers. But let's say X and Y are 1 and 2. So if you are writing this and you are saying this is equal to 8, let's say, then it is going to go and look for a matrix F. If there's a matrix F and matrix F index 1, 2. And if it does exist, then it's gonna put 8 at that position. So again, in matrices, we're gonna discuss today later. But as a variable name, this is not allowed. So you cannot use parentheses as a variable name. You cannot use comma as a variable name. So you can just write F as your variable name, or you can write fxy as your variable name, whatever you want. But you cannot use exactly the way that you're writing in math, because in math, of course, you're saying that this function F is a function of X and Y. This is not allowed in MATLAB because parentheses and comma, they are not valid names, not valid characters that can be used in a variable name or a file name. So I'm just going to use fxy. And then I'm going to do 2 times x plus 3 times y. Now observe, if I'm using math, then y, 3 is multiplied by y, and the result is divided by 5 before it is multiplied by x plus 5. In math, generally, that's how you're going to read this equation. Now, if you want the whole denominator to be dividing the whole thing, then you're going to put a parenthesis over here as well. And then you're going to write the whole thing in parentheses. But if the parentheses are not here, then the equation, the way it is written is 3 times y divided by 5 times x plus y. And that's how I'm going to write 3 times y divided by 5. So in this case, first 3 is going to be multiplied by y, and then this is plus not equal. First 3 is multiplied by y, then divided by 5, and then the result is going to be multiplied by x plus y. So again, make sure that you write the equation correctly. Where the parentheses are to be used, use them wisely. Where they're not used, then do not put parentheses at those spots. So if I'm writing in this equation, I'm giving you this equation written mathematically. That's going to be fxy equals 2x plus 3y divided by 5, x plus 5, 2x plus 3y divided by 5. Oh, so 2x, only 3y is divided by 5, not the whole thing. Oh, what did I write? Comments, where is my eraser? Two x plus 3y divided by 5 times x plus. This is how this equation is written basically. And then the next part of the equation is negative 5y over 4x minus 5y over 4x. This is how the equation is written. So again, be careful when you're implementing equation from how it is given in the arithmetic form into writing MATLAB code. Then make sure the parentheses that you're using, you use them appropriately. Otherwise, the equation is not going to be evaluated correctly if you don't use parentheses appropriately. So 3 times y divided by 5, x plus y. And again, it is the same thing. Even if you put parentheses here, it's going to be the same thing. It is not going to change anything. So I usually don't like to put, if the parentheses are not required, redundant parentheses, I don't like them to like those parentheses. So I'm just going to write this down, x plus y, and then the next is negative. Now this is going to be 5 times y, parentheses in the numerator. Sorry, it's not 5y. And so here I made a mistake here again. Let me go back. It's 5y over 4x. So 5 is multiplied by y over 4x, the way it is written over there. It is 5y over 4x. This is how it is written. So 5y over 4x. So 5 times y divided by 4 times x. This is how you're going to write this. Then you're going to save it. And to execute a program, this is the run button right here. So you're going to run the program using this run button. It's going to ask you a question. It's going to ask you, should I change the directory because the program is saved in this directory, but my command window, my Octave, is not yet located to where the program is saved. It's located to some other current directory, some other directory. So you have a few options. As you can see, you have to change directory. You can cancel it, or you can do add directory to load path. I won't advise you to do add directory to load path. What's the load path? Load path is basically multiple folders. When you install MATLAB, then it installs multiple folders, which are toolboxes. In toolboxes, you have multiple functions that are that MATLAB use or Octave use. So it is when it starts Octave or MATLAB, it loads all of those folders in the path, in the execution path. So if you call any function from any of those folders, you don't have to change the directory. It's gonna just call that function from that specific folder. So if you add your directory to the load path, it's going to automatically load your directory as well. And then you can call whatever you're writing in any of your function, you can call it, or you can execute your program. That's fine. But you don't really want to keep adding different directories to the load path. It's just not wise. So all you have to do is to change directory. And if you change directory, observe the current directory is changed to where your program was saved, because you can only call program where it is saved if your directory is not in the load path. So it calculated the value of fxy, which came out to be 59.029. You can also call the program from the command window by going up arrow, and it's going to show you that I called MATLAB-1, I executed this program, and then you can hit enter, and it's going to call the program, or you can write the name of the program in the command window, and it's going to call it as long as you are in the same directory where the program is saved. So the result of my calculation is 59.029, and it shows you because I did not put any semicolon after this. If I put semicolon after this line and run it, then it's not going to show me the result. That does not mean it's not calculating the result. It is calculating the results. It's not just showing me the result. You can always type the variable fxy, and it's going to show you the value of that, but it's not going to display if there is a semicolon after that line. So this is how you basically operate an equation. Again, example is given over here. All right, exercise 1. Let's do this thing. Let's take about 15 minutes. During this 15 minutes, I want you to work on this exercise and take a break. And then in 15 minutes, about 6:45, then I will ask you what is the result that you're getting for this exercise. You can write it either in the command window, or you can write it in the file editor and execute the file, whichever way you want. You can do wherever you want. But let's do that. Let's take 15 minutes, work on this program as well as take a break, whatever you want. Well, you have to do, but don't take a break if you're working on the program. Take a break and then come back and work on the program, or work on the program and then take the break. Because I want you to finish this and let me know what you get. But I will see you in about 15 minutes and I'll ask you what did you get. So that's part of the homework, exercise number 1. If you did get the result that we discussed, that should be the result, I think, 0.074. Okay, moving on. So MATLAB has a bunch of other mathematical functions built in, trigonometric functions and all those. A list of some of the commonly used functions are given in this table, table 2. Absolute function basically gives the magnitude of a number. It also calculates the magnitude of a complex number. So if your complex number is x plus jy, then the magnitude of the complex number is calculated as, you know, x squared plus y squared. And the absolute function does that as well, calculates the magnitude of a complex number. I think it's in the other table, one of the other tables, complex number discussion. If you want a square root, you can use the square root function, a square root of x, or you can just do x to the power 0.5. Both are fine, but a square root is a built-in function to calculate the square root. Round function rounded off to the closest integer, floor rounded off to the previous integer, ceil rounded off to the next integer. Sine basically is a Boolean function that gives you -1 if x is less than 0, and 1 is x is greater than 0, and 0 if it is 0. And likewise, you have exponential function e to the power x using the exp x. Now, some students use e to the power. Let's say if I say, yeah, you know, exponent of x, then they do e to the power x like this instead of using exp of x. Do not use e to the power x, because if you're using a variable in your program and assigning a value to that e variable, then e to the power x is going to take that variable and take the power x of that variable. So that's not a wise way to use exponent function. Although it does calculate the exponent, if you don't have a variable e, then it's going to calculate the exponent. For example, if you have exponent of 5, exp5, 148.41, and e5, it's going to also calculate 148.41. But as I said, if you're assigning e is equal to 54, and then if you take e to the power, what was it, 5, then it's not going to do exp of 5. It's going to take the value of e that you have and then raise it to the power 5. So make sure you use the exponent function exp anywhere, anytime you need to take the exponent. Log function is the natural log of x. Log to the base 10 is the log 10 of x. And again, you have sine function, cosine function. Now, in MATLAB, if you use sine, cosine, tangent, then these functions, you require the angle to be in radians, not in degrees. If you have degrees, then you can just use sine d, cosine d, tan d, and then x can be in degrees. Remember, in LabVIEW, you could only process trigonometric function if the value of the phase is in radians. But in MATLAB, you have both functions. But even if you're using sine of x and if your x is in degrees, you can always convert that x times pi by 180. You can always convert that into radians and then calculate the value of sine and cosine such that you don't have to use sine d, cosine d, but sine d, cosine d, they are present in MATLAB. So no conversion is required. If your angle is in degrees, just use that sine d, cosine d. Sometimes the problem is when you have two values, x and y, one is in degrees, one is in radians. So this is in degrees, this is in radian. And let's say you are doing sine for xy. In that case, of course, first you have to convert both the angles into the same argument. And for that, always convert the degree into radians. So you have to convert degrees into radians, and then you have to multiply x and y, and then perform the sine of that. So in MATLAB, although sine d, cosine d, tan d, all of them are gonna take the apply the trigonometric function if your angle is in degrees. And if your angle is in radians, which most of the time it is, then sine, cosine, and tangent. Likewise, to calculate the angle, you can use a sine x. It will calculate the angle from the value of x. Again, if you calculate the angle in degrees, a sine dx, and then cosine, sine, and all those things. There is another function, a tan 2 y comma x. This is generally used for, again, complex numbers. If you want to know what is the angle associated with that complex number in polar form, then you can use this to calculate the correct angle of the complex number in radians. So this table is good. Oh, by the way, in MATLAB, you also have help function available. Let's say help of sine, not I help of sine. And it's going to give you a help function that shows you what is the syntax of sine function. And it will also show you some of the relevant functions, which sometimes comes very handy. MATLAB help is better than Octave help. And MATLAB help is available free online. So you can just go and then say MATLAB sine function. And then you can check the help. It's going to show you online what is the help for the sine function. It's going to show you an example, a simple program as well. So MATLAB has is much more comprehensive as compared to the Octave help. And again, it's available online for free. So you can check the MATLAB help as well for any function. Octave help is good as well, but not as comprehensive as MATLAB. Okay, what else do we have? Let's see. Exercise 2 you have to do for next week as well. Again, two values are given to you. X is equal to 25, y is equal to 2.34. Both values are angle because you're using trigonometric functions. However, x is in degrees and y is in radians. And you have to evaluate this function. So make sure use the correct trigonometric function or convert x in radians or y in degrees if you're using whatever function you're using. And you have to evaluate the value of this expression. And again, if you want, you can do exercise 1, exercise 2, all of them in the same M file. Just put comments before you start the new exercise. Just put comment that this is exercise 2, exercise 1, exercise 2, stuff like that. Examples are given here again. Try to do examples, not just read examples or totally ignore examples that many students do. They don't even look at example. But examples help you a lot. And many times students don't even bother to read examples, forget about doing the examples. So do examples as well. They're gonna give you good practice. And the code for examples are given. You don't necessarily have to look at the code before you write the example. Write the example first, execute it, see what result you're getting. If you're getting the same result as I'm getting, your code will be good. If you're getting different result, then you can cross-check your code with my code. So again, many students, when in this example, you can see e to the power x is used, natural log is used, and then in the next exercise, again, you're using e to the power xy. So many times, students, again, if you look at this example, I'm specifically using exp of x. And many times when I am grading exercise 3, I see many students are using e to the power x, e to the power y, e to the power this and that. If they do this example, they will see that you have to use exp function to calculate the exponential function. So do the examples, please. Help function I already discussed with you. some of the constants that are present in MATLAB and the complex number. So if you want to write pi in MATLAB, you just have to spell out pi. So 2 times pi. So you have to just spell out pi if you want the value of pi. Infinity is going to be, of course, INF. Anytime your result is infinity, it's going to show you with INF. Anytime your result does not exist, it's going to show you not a number, NaN. I and j both are used for imaginary numbers. So if I want to represent imaginary number as w is equal to 2 plus 3j, that's a complex number, which is 2 plus 3i. If you want to calculate the magnitude of the complex number, because remember, complex numbers can be represented either in the rectangular form or polar form. And once again, guys, if you forget about complex numbers, I believe what we did was, we discussed that in LabVIEW, but if you forget about complex number, please go ahead and refresh your memory about complex numbers, because you will be using it in every class pretty much. And students struggle so much with such a basic idea of complex numbers, and they lose a lot of points. There's no reason that you should be losing point just with the complex number when they're nothing, basically. They're same as real numbers. But if you forget about the manipulation of complex number, polar form, rectangular form, then please go ahead and I have 4 videos on my YouTube channel that deal with the complex number, starting from the basics of complex numbers, mathematics of complex number, applications, and then MATLAB, how to do complex number in MATLAB. So you can watch those lectures if you want. But please make sure you refresh your memory about complex numbers, because you're going to be using them in circuits, control system, signal processing, power electronics, power system, every class that you touch, especially if you're electrical concentration, you're going to be using complex numbers. And I see students struggle in every class because they just don't want to learn complex numbers. They have learned it before, and since we don't use it, we forget about them. But there's no excuse that you cannot go and refresh your memory instead of losing points. So please refresh your memory about complex numbers. So rectangular form of complex number, polar form, that includes magnitude of a complex number and the phase of the complex number in the complex plane. In MATLAB, as I said, absolute calculates the magnitude of the complex number, which is the square root of real part square plus imaginary part square. 2 square plus 3 square, square root of that. And phase of the complex number. Anybody remember how to calculate phase of a complex number given in the rectangular form? And again, if you cannot answer this question, that means you forget about complex numbers. So you need to review complex numbers. How to calculate phase of a complex number if you know complex number given in the rectangular form? Is the tangent inverse of y over x. And again, if your number is in the second quadrant or third quadrant, then you have to, second quadrant, if you're calculating tangent inverse, then you have to add 180 degrees. And if your number is in the third quadrant, and if you're using tangent inverse of y over x, you have to subtract negative 180 degrees to get the correct value. So it's tangent inverse of y over x. A tan of y, which is 3 in this case, which we can also use as image of w. Image extracts the imaginary part of a complex number, and real function extracts the real part of the complex number. So image of w divided by real of w. Tangent inverse is represented by a tan, and that is going to give you the angle in radians. If you want to convert that angle into degrees, then you multiply that by 180 and divide by pi. So 56.31 degrees is the angle associated with the complex number 2 plus 3i. This number is in the first quadrant because both x and y, real part and imaginary part, are positive values. In the second quadrant, x is negative, y is positive. Third quadrant, both are negative, and fourth quadrant, y is negative and x is positive. Now, the built-in function in MATLAB is angle function that you can use to calculate the angle of a complex number given in the rectangular form. So angle of w. It's going to give you the angle. And if you want in degrees, then again, you just have to multiply that by 180 and divide by pi. That's going to give you in degrees. And likewise, a tan 2 is another function, a tan 2, image of x, comma, real of x, yn x. No, 8, no, not 8 and no, not x, sorry, w. I meant x. W. So that's another function to calculate the angle. So if you're using only tangent inverse function, and if your angle, if your complex number is in the second or third quadrant, if it's in the second quadrant, tangent inverse function is going to give you in the fourth quadrant angle. And if it's in the third quadrant, tangent inverse function is going to give you in the first quadrant. So tangent inverse is not good. If the number is in the second or third quadrant, you have to add 180 degrees to your result if you're using tangent inverse function. If the number is in second quadrant, and if you have to subtract 180 degrees from your result if you're using tangent inverse function if it's in the third quadrant. But if you're using a tan 2 or you're using angle function, it's going to give you the correct angle, irrespective where the complex number is located in the complex plane. So anyways, this, some of the functions, the complex that deal with the complex number are given in this table. Real of x, I already showed you, imaginary of x, conjugate of x, angle, and absolute. Anybody remember what does conjugate of a complex number mean? Anybody remember that? I'm sure all of you have taken complex number in pre-calculus.
Yeah, I think I remember. I think you, like, if it's like, I don't know, like 3 plus 4i, then you multiply by like 3 minus 4i, something like that. Right?
Yeah, you don't multiply it, but the conjugate of a complex number given in the rectangular form, let's say 3 plus 4i, as you said, is simply you reverse the sign of the imaginary part. So it's going to be 3 minus 4i. That's
right. Okay.
You don't multiply it with anything, but you just change the sign of the imaginary part. If the number is given in the polar form, phase and magnitude and phase, then you change the sign of the phase. If it's a positive phase, you change it to negative phase, and if it's a negative phase, you change to the positive phase. That's called the conjugate of complex number. Now in MATLAB, if your number is complex, all the mathematical manipulations are done when the number is represented in rectangular form. So MATLAB cannot deal with the polar form, number in the polar form. Many calculators can do. I don't know, I have not used calculator in ages, basically, but I know many calculators can deal with both rectangular form of complex number as well as polar form. But MATLAB can only do rectangular form. So if the number is given in polar form, generally you first convert that number in MATLAB in rectangular form and then use it for any mathematical multiplication, division, and anything that you're doing. Okay, exercise 3 is another exercise that you have to do. And then this exercise, you have 3 equations. First equation is a function of x and y. Second equation is the function of xy as well as the result from the first equation, v1. And the third equation is function of all 4 variables, xy, v1, and v2. So you have to write this program, all 3 equations, and then calculate the results of v1, v2, and v3. And again, it's going to be similar way that I showed you. You're going to write the code in the editor. And at the start of the file, write down your name, basically write down the name, the date that you are creating the program. And again, if you're writing all the codes in the same file for next week, that's perfectly fine. You can write all of the codes in the same file for the next week. I will tell you which programs you should not write in the same file, but next week, fine. Every code in the same file is perfectly fine. Just make sure that you divide. So let's say if this is your exercise 1, so this is going to be EX1. This is the first program. And let's say you are doing exercise 2, then just put a comment again. EX2, and whatever, you don't have to write much, but if you want to write the description, whatever you're doing, that's fine. But I'm just going to write down, this is my second program, and perhaps it might be better just to put a line between them. So just to separate them, you can put a line like this as a comment. So for next week, I think I will prefer if you put all of them into one single file, so I can just open the file and run and check the result of all of them instead of opening separate files.
Professor.
Yeah.
So I was kind of like working the exercises along as you were lecturing.
Yeah.
And I submitted them as all separate files. Is that okay?
That's okay. You can still submit until next week. So you can have as many attempts as possible. So just submit it again and put all of them in a single file.
Okay.
Yeah. All right, so exercise 3. Now, one of the most important things that you'll be using pretty much most of the time in MATLAB, which are how to deal with vectors and matrices. Matrices and vectors are the same thing, except vectors have a single row or a single column, and matrices have multiple rows and multiple columns. So I'm going to discuss both of them together right now. Now, okay, so vectors and matrices. Let's go here. Let's do CLs. In MATLAB, if you're defining a matrix, and we discuss matrices in LabVIEW as well. So if you're defining a matrix in MATLAB, you define in square brackets, and you can define 1, 2, 3. That's the row of a matrix. And if you want to change the row, go to the next row, you put a semicolon, and 5, 6, 7. So this will define a matrix with 2 rows and 3 columns. You can check the size of a matrix, that is how many rows and columns, by the function sign, the size. And it's going to show you that it has 2 rows, the first number, and 3 columns. You can also use a function called length of A. That shows you the maximum dimension, whether it's the column or the row, whichever is the maximum dimension. So in this case, there are more columns than the rows. It's going to show you that length of A is 3. So matrices can be 2 by 2. Matrices can be 2 by 3. Whatever dimension of the matrix is, 3 by 3, 2 by 2. If the matrix, and matrices can be multidimensional. This is a 2 by 2 matrix, but you can also have 3. You can also have 3 dimensions of matrices. We are not going into 3 dimensions right now, so we're going to restrict ourselves to 2 dimensions only, rows and columns. But you can also have 3-dimensional matrices, and we use them, of course, in the upper level, not at the bachelor's level, but usually at the master's level, if we are dealing with magnetic fields and stuff. So again, as I said, I'm going to restrict our discussion to 2 by 2 matrices, which you can see A is a 2 by 2 matrix, 2-dimensional matrix, sorry, not 2 by 2, 2-dimensional matrix with a dimension of 2 rows and 3 columns. So it's a 2 by 3 matrix, 2 rows and 3 columns. You can access any position of the matrix through its index. Now, in MATLAB, index start at 1, both for rows and column. Remember, in LabVIEW, index started at 0. In MATLAB, index starts at 1. So if I want to access the first row and second column, then I'm going to write A1, 2. A is my matrix, and 1, 2 represent the position in that matrix, the index in that matrix, which is the first row and the second column. And it's going to tell you that the first row and the second column in A has the value 2. If you want to replace a value similarly, then you do the same thing. You assign a new value. A1, 2 is equal to 6. And that's going to change the value of 2 to a 6. Now, remember, again, as I mentioned earlier in today's lecture, this is not a variable name. A parentheses 1, 2 is not a variable name. The variable is A. 1, 2 in parentheses represent that location of that matrix, which is represented by the variable A. So don't assume that variable name is A, parentheses 1, 2. It's not, because the rules for variable name does not apply on this. Variable name is A, 1, 2 is the location of A, which represents a matrix. If you want to change all the values either in a row or a column, then let's say you want to change the second row to different values. Then this is how you're going to write it. A colon, A2, sorry, second row, comma, colon. Colon means that all the columns, second row, all the columns, is equal to 10, 11, 12. So it's going to take the second row and replace all the columns, which are 3 columns, by 10, 11, and 12. Likewise, if you want to change second column and both rows, then you do the same thing. A, all rows of the second column equals 5 and 6. So 5 is the first row and 6 is the second row of the second column. So colon is used if you want to change all the rows or all the columns. Likewise, if you want to delete any row or any column, you do the same thing. A, let's say you want to delete the second column. To delete a column or delete a row, you use empty matrix. So you use basically 2 square brackets opening and closing without anything. And it's going to delete that specific column, which is the second column, all rows, second column. What else? So we're discussing vectors right now. So in vectors, so vectors is a subset of matrix. Vectors are matrices with either one column or one row. So one of the dimension is 1. Either you have a single row matrix or a single column matrix. And they are called row vector or a column vector. For example, if I have B is equal to 1, 4, 5, 6, 8, 19, then this is called a row vector because it is one row and 5 columns. But since there's only one row, it's called a row vector. And likewise, if you want a column vector, there are 2 ways to represent column vectors. Either you do like regular with the semicolons. 45 is the first value of the vector row, the column vector. 23 is the second row, and 89 is the third row. To me, generally, it is kind of a little tedious to put semicolons. Generally, what I advise you to do if you want to create a column vector is you create a row vector. Let's say 45, 23, 12, 34, 100, whatever. Create a row vector and then put an apostrophe. And what does this apostrophe does is it transposes the vector. And if you remember what transpose of a vector is, if you ever heard about it, or transpose basically exchanges rows and vectors. Transpose is an operation on matrices that convert rows into columns and column into rows. So if you put transpose with apostrophe, it's going to change the row vector into a column vector, and that's easier to write. A more easier way to write a vector or a matrix is not to even use the comma, because you can also use the spaces. E is equal to 1, 4, 8, 9, 10. Instead of commas, you can use the spaces, and that will also define a vector or a matrix. The only difference in the matrix is going to be that if you have to go to the next row, you will still have to use a semicolon. 5, 9, 12, 23, 45. But when you are in the same row and you are defining different columns, then you don't really have to use a comma. You can just use a space. So that's another way that I prefer to write matrices, because again, it's less work. All the, comma is not difficult either. So this is how you define matrices and vectors. Now, since we are, I think the example or the exercise that you have to do is the exercise based on vectors. So I'm just going to discuss the vectors today. And next week, we are going to continue the discussion of matrices. 7 exercise 7, what is exercise 7? C exercise 5, 6. Okay. Okay, this is exercise 7. All right, yeah. So this is using matrices. Anyways, so let's go ahead and finish the discussion of vectors, because exercise 4 is based on vectors that you are doing. So arithmetic of vectors. Now remember, in LabVIEW, when we were discussing matrices and arrays, we discussed that when you're adding matrices, of course, you can add matrices, 2 matrices. The dimension of each matrix should be same in order to add their corresponding elements. Likewise, if you're subtracting 2 matrices, the dimension should be same and the corresponding elements are subtracted. But if you're multiplying 2 matrices, there was a condition on matrix multiplications. Anybody remember that condition? What is the condition of multiplying 2 matrices?
The number of columns has to equal the number of rows.
That is correct. So if you're multiplying 2 matrices, let's say A is equal to 2, 3, 6, 9, 8, 7. Now in A, you have 3 columns and 2 rows. So if I have a matrix B, and if I want to multiply that matrix with the matrix A, then B must have at least 3 rows to make them equal to the number of columns of A. So if I have 1, 2, 3, 4, and 5, 6, then I have 3 rows and 2 columns. And now I can perform the matrix multiplication A times B, and it's going to produce a matrix C. Matrix C will have the number of rows same as matrix A and number of columns same as matrix B. As you can see, matrix C has 2 rows, which are the number of rows of A, and 2 columns, which is the number of columns of B. And they are comfortable to be multiplied to each other. If I have another matrix D, which I do 1, 7, and 4, 5, and so I have now 2 rows and 2 columns. So if I do now A times D, then it's going to give me an error. Operator multiplication, non-conformant argument. Operation 1 is 2 by 3, operation 2 is 2 by 2. So this error is going to happen if you are attempting for a matrix multiplication, but the 2 matrices that you're multiplying, they are not the number of columns for the first matrix is not the same as the number of rows of the second matrix. So you're going to see this type of error. That is going to tell you that operation 1 is 2 by 3, 2 rows, 3 columns, and operation 2 is 2 by 2. Anytime you see this problem, know that your matrices have different dimension and you're performing matrix multiplication operation. Now, when we were discussing arrays in LabVIEW, I told you that if you use the regular multiplication block with 2 arrays, it's going to multiply the corresponding elements of the arrays. And if you use the matrix multiplication block, then it's going to apply the matrix multiplication operation. In MATLAB, if you use only the multiplication symbol, it performs the matrix multiplication operation between the matrices or between vectors, because vectors are also matrices. However, if you want to perform what we call array-wise operation, that is the first element of the matrix multiplied by the first element of the second matrix. The second element of so let's say if I have C and D, they have the same dimension, right? And if I want to multiply 41 times 1, 52 times 7, 68 times 4, and 92 times 5, the corresponding elements of C and D, then if I do C times D, it's going to work because number of columns of C are 2, number of rows of D are 2. So it's going to work. However, the multiplication is going to be matrix multiplication. Matrix multiplication is going to be 41 times 1 plus 52 times 7. That's going to be the first element. 41 times 4 plus 52 times 5. That's going to be the second element, and so on and so forth. So this is the matrix multiplication between C and D. But if you want to multiply corresponding elements only, 41 times 1, 52 times 7, 68 times 4, and 92 times 5, then instead of using just the multiplication sign, what you will have to do is use a period before the multiplication sign and then put multiplication sign. And then it's going to perform what we call the array-wise multiplication. That is, it's going to take the individual component of C and D and then multiply them together. 41 times 1, which is 41, 52 times 7, 364, 68 times 4, 272, and 92 times 5, which is 460. So be careful what type of operation you're performing. What is the requirement of the operation? Are you performing matrix multiplication, or you're performing array-wise multiplication or array-wise operation? One will require you to put a period before the multiplication sign, and one does not require you to put the period before the multiplication sign. In general, anytime you're performing array-wise operation, you are going to put period before multiplication sign, before the division sign, and before the power sign. Anytime you are performing array-wise operation. Array-wise operation again means that you are operating on the individual components of either the same matrix or vector or between two matrices or two vectors. Give you an example. Let's say that, oh, by the way, we're discussing vectors. So vectors, as I showed you how to define vectors. That's a row vector, column vector. There's another way to define vector, which is, let's say you are evaluating an expression, which is a function of x, and x goes from 0 to 10 with an interval of 0.1. So instead of writing a vector x is equal to 0, 0.1, 0.2, all the way up to 10, which is, it's going to take forever, you can define this vector if it has a starting value, ending value, and a specific step size. You define it as start value and step size and end value. And the whole vector is going to be defined, which you see on your screen. So if you're evaluating an expression, which is a function of x, and x has a range, generally that's how you define x. Instead of typing each value of x separately in a vector, you define x like that, and then you evaluate your equation on x. So if you have an equation on x, let's say your equation is 4x cosine 5x. Let's say you are evaluating this expression. Now let's go ahead and write this first. So we define x, of course, as I showed you, we define x from 0 to 10 with an interval of 0.1. And let me write y is equal to 4 times sine. Now, what is our intention? Our intention is what? That this equation should be evaluated for each value of x, starting from 0 to 10 with an interval of 0.1. That's our intention. But if I write the equation 4 times x times cosine of 5 times x, and I execute it, observe it's going to give me the same error. Non-conformant operation. Operation 1 is 1 by 101. Operation 2 is 1 by 101. Now, why it is doing that? It is doing that because when this is evaluated on x, was a vector with 1 row and 101 columns. When this is evaluated on x, it will result in a vector with 1 row and 101 columns. And when this is evaluated on X, again, it's going to give you one vector with 1 row and 101 columns. So I put multiplication sign between these two. That means if this is my vector and this is my vector, the number of columns of my first vector must be equal to number of rows of my second vector if I want to apply the matrix multiplication operation, because I'm using the multiplication sign between that. However, what was my intention? So it gave me that error that matrix multiplication operation is not possible. It gave me that error. What was our intention? Our intention was starting with x is equal to 0 and then 0.1, 0.2, evaluate this expression for each value of x. In that case, I will have to perform array-wise operation. And I'm going to go ahead and perform array-wise operation just by putting a period before the multiplication sign. Now, it's going to calculate the sine 4x value for the first value of x and cosine 5x value for the first value of y, multiply them together, generate the result. Then it's going to take the second value of x, evaluate both sine 4x and cosine 5x, multiply them together, generate the result. So now you can see that the result is generated. Total number of points calculated 101, again 1 row, 101 columns, and no error. So this is important. This is an important thing that you need to implement as when you're performing array-wise operation. Anytime you are multiplying two matrices or two vectors, in this case, through array-wise operation, you have to put a period before the multiplication sign. If you are taking power of a matrix with another matrix, you have to put period before the power sign. Or if you are taking a square of a matrix such that you are taking a square of each element of the matrix or vector, you have to put a period before the power sign. If you are dividing a matrix by another matrix such that both matrices have the same number of elements, that is, you're dividing the first element of A by the first element of B, second element of A by the second element of B, then you have to put period before the division sign. Or even if you're dividing a constant value by a matrix, so 1 over A is a matrix, so 1 over the first element of A, 1 over the second element of A, 1 over the third element of A, you still have to put a period before the division sign. However, if you're multiplying just a constant value by a matrix or a vector, in that case, you don't have to put a period before the multiplication sign. And that's what you see. I have no period before the first multiplication sign, that is after 4. However, if you do put period, it's not going to give you an error. It's just going to be redundant period. If you're multiplying a constant value by a vector or a matrix, you don't need a period before the multiplication sign. If you do, if you put a period, it still gives you the correct answer. So if you're confused about that, you can still put a period when you're multiplying a vector and a constant value. But if you're taking the power of a vector, that is each value of the vector, power of each value. If you're multiplying two vectors or two matrices which have the same size, corresponding elements, or if you're dividing two vectors or two matrices which have the same size, or a constant, dividing a matrix by dividing a constant by a matrix or a vector, then you have to put period before the mathematical operator. And that is called array-wise operation. Instead of matrix operation, you're performing array-wise operation. That is operation between the individual elements of matrices or arrays. Let's go back. Okay, so this is what I'm describing here, mathematics of vectors. And again, make sure you go over this. I already discussed with you how to generate vectors and all those things. So observe in this exercise, as I showed you in this exercise right here. In this exercise, you have two vectors, x and y, both have the same length, 5. And you are evaluating this expression on these vectors. 4x cosine y, 2 log of y, natural log of x plus this. In this case, you're performing array-wise operation because you cannot perform matrix operation. You cannot do x times cosine of y. It's going to give you, again, non-conformant error. So you are performing array-wise operation. You're taking first value of x, first value of y, plugging those values here to get the first value of z. Second value of x, second value of y to get the second value of z, and so on and so forth. So you're expecting that the length of z is going to be the same as the length of x and the length of y, which is 1 row and 5 columns. So I wrote the code and observe the period that I'm using between the multiplication sign, between this multiplication sign, between this multiplication, before the division sign, and power sign, x to the power y. And the result is going to be 5 values, as I said, 5 columns and 1 row. So do this exercise because, again, a student jump to exercise 4, which again requires you to do array-wise operation. So you have to use periods. People jump to this exercise, totally ignore this example, and then they produce incorrect results, or they produce no result because they're error. So if they only do this exercise, it will be much easier to do this exercise as well. In this exercise, of course, as you can see, I have x, y, and z, 3 vectors that I'm defining, each the same length, 1 row and 5 columns. And I have this expression w that I have to evaluate. And this equation is a function of x, y, and z, all of them. So you're going to perform array-wise operation on this to calculate the value of w for each set of x, y, and z. The first set is going to be 0.2, 2, and 1. The second set will be 0.4, 4, and 3, and so on and so forth. So you're not performing any matrix operation here. You're performing array operation here. So make sure you put the periods appropriately. Again, what is the condition for putting periods? Carry out addition, subtraction, multiplication with the element of 2. So carry out multiplication and division between 2 vectors of the same dimension. Before the multiplication or division sign, you have to place a period. For division sign, even if you are dividing a constant value by a vector or a matrix, you will still use a period if you're performing the array-wise operation. Also, you have to place a period if you want to take power of each element of a vector. So keep that in mind, please, when you are doing exercise 4. My advice, do example 4 first, don't submit it, but do example 4 first. And that is going to give you some practice to do exercise 4. So that you won't make a mistake. Yes, go ahead. Robert.
I noticed between exercise 4 and example 4, syntax-wise, does it matter for like y and z groups? They have commas or they don't have commas?
Yeah, as I showed you that it doesn't matter because both of them are going to generate a vector.
Okay.
You can put comma or you can put a space. You just have to put a space, remember, you cannot put right next to it. Either you put a space between the 2 numbers or comma. In both ways, it's going to generate a vector, a row of vectors.
Okay, thank you.
I'm giving you a hint over here as well for this exercise. Since first element of z is 1, natural log of 1 is 0, hence the first answer should be infinity, because you have a 0 in the denominator right over here. The first answer is, I don't know if it's infinity. Yeah, it's infinity, INF. It's not a number. It's going to give you infinity. So these are the 4 exercises that you're doing for next week. As I mentioned, do all of them in the first in the same file, and then just name the file as your first name _ last name _ MATLAB homework 1. That should be good enough.